Hi everybody. So in the past video what we did was we talked about polygons and we spent a lot of time with quadrilaterals. Today what we're going to do is we are going to focus on triangles. So we are going to not only know how to name them but also how to find either missing values or missing angles in a triangle. So the first thing is we have to talk about the different types. So I'm sure that you are familiar with all of these, but just as a reminder, the first one is that we have the equilateral triangle, and that's going to be where all three sides and all three angles are going to be congruent. And in fact, one thing that may be useful is to remember as well that an equilateral triangle is also called equiangular. We don't see that name as often, but it is possible for it to show up, and you need to be aware that just means that you're dealing with an equilateral triangle. Then the second one is the isosceles triangle here. And the key part is that there are at least two congruent sides and angles. So an equilateral triangle is actually also isosceles. We also have the two congruent angles as I mentioned before, and they're going to be located right there. And on a later slide, I'm going to talk a little bit more about isosceles triangles. Then we have the scalene triangle, and that's going to be no congruent sides or angles. So everything inside the triangle is going to be different. Then we also name them based off their angles. We already talked about the equiangular, but we do have the acute triangle, and that means that all angles are acute or all are less than 90 degrees. Then we've got the obtuse angle. In an obtuse triangle, it's going to be located right there. And so that one is between 90 and 180. And then the last one is the right triangle, and that one we know that one angle has to be 90 degrees. Alright, so as I said, we were going to talk a little bit more about the isosceles triangles, and there are special parts of it that we need to be aware of. So the two sides that are congruent in an isosceles triangle are always going to be called the legs. And therefore the one side that is not congruent is the base. Then one thing also is that we've got these two angles here, the base angles. And those are always going to be congruent as it says down here. One easy way for us to identify where the base angles are is that they are across from the legs. So the angles that are across from the congruent side in an isosceles triangle, those two must be congruent as well. Since these are going to be the base angles, we also then up at the top have the vertex, or sometimes you also hear it called the vertex angle. And that's just talking about then this angle here that is not congruent with the other two angles in the picture. So you probably are already familiar with this, that triangles will always add up to 180 degrees, and specifically we call that the triangle sum theorem. So in this case, in this question, we are asked to find the value of x in the picture. So we need to first start by identifying what type of triangle we have. I notice we've got two marks here showing that those legs are congruent. Therefore, this must be an isosceles triangle. And if this is isosceles, then I know that those two angles must be congruent. And if we know that this angle is x, this angle over here must be x as well. So we can then set up an equation, x plus 70 is equal to 180 degrees. Now we just need to solve it. We have like terms here that can combine, so we will now get 2x plus 70. We need to subtract 70 from both sides. That gives us 2x is equal to 110. Oops. And then we have to divide both by 2. And x equals 55 degrees. Okay, now in this one, can you tell what type of triangle we have? hopefully you're able to see, since all three sides are the same, they're all congruent, this one is equilateral. And that means that all three angles must be congruent. So maybe some of you have already gone ahead then and figured out what's the measure of one angle, but here's what I'm going to do. If we know that this top one is 2x plus 10, then we know that this here is 2x plus 10, and we know that this one over here is also 2x plus 10. So rather than write 2x plus 10 three times, I'm going to simplify this and just say 3 times 2x plus 10 will be equal to 180. And instead of distributing the 3 into the parentheses, I'm going to divide both sides by 3. And that means then that 2x plus 10 is 60. Or, in other words, each one of these angles, that one is 60 degrees, that one is 60 degrees, that one is 60 degrees. So we can go ahead then and finish solving this. We're going to subtract 10 from both sides. We're going to get 2x equals 50. And then when we divide by 2, we see that x is 25 degrees. Okay, so as usual, what we should do first is we should label the type of triangle that we have so that we know how to solve this. So starting off, I see we've got two sides that are congruent, so that means that this is an isosceles triangle. Then the second thing I noticed is that we have a right angle. So it's an isosceles right triangle. Therefore, these two angles must be the same, so this down here is also 3x minus 15. And then we can add all of these together and set it equal to 180. So we've got 3x minus 15 plus 3x minus 15 plus 90 is going to be equal to 180 degrees. Now, I can solve it this way. When I'm done, I'm going to actually show you a shortcut that would have gotten us the answer in a faster way. So let's combine our like terms first. 3x and 3x are going to make 6x. Then I see that we've got negative 15 and negative 15. That makes negative 30 plus 90 means that we're going to have plus 60. Okay, we're going to subtract 60 from both sides. We have 6x is equal to 120. We divide both sides by 6. And x is equal to 20. Now, I did promise you that there's going to be a faster way that we could solve this, and I'm going to demonstrate right here. If we already know that this angle is 90 degrees, then we know that these two here add up to 90 degrees as well. And that is going to be, I'm sorry, I lost my train of thought there. So if those add up to be 90 degrees, then what we could do, instead of 3x minus 15 plus 3x minus 15 equals 90, I'm going to write this left side a different way. Kind of like what we did in one of the earlier questions. If there's two of them, why don't I just write 2 times 3x minus 15 is equal to 90. Then I can divide both sides by 2. And I get 3x minus 15 is equal to 45. So we actually have figured out that each of these base angles had to be 45 degrees. And that would have been a faster way for us to solve this. Now we can add 15 to both sides. We have 3x is equal to 60. And then you can see as well that we would have gotten 20 as an answer. Cool. Okay, for this question then, what I want you to do is pause the video, try to solve it on your own. When you are done, then start up the video again, and I will demonstrate how to solve it. Alright, now that you have tried this, I am going to show you how we should have answered this. So looking at the triangle, I noticed that there's no distinguishing characteristics. There's nothing that appears to be congruent. I don't really know anything about this, so it looks like that we are just dealing with a scalene triangle, as in everything is a different value. So we should just add all three angles together and set it equal to 180 and see what happens. So I'm going to start with 2x plus 10. Oh, I'm sorry, I totally missed something. It can't possibly be scalene. It told us that it's isosceles. I'm sorry about that. So for this question then, what we should do, now let's just say those two happen to be congruent. So then, if those are congruent, we should just set them equal to each other. 2x plus 10 is equal to 90 minus 2x. Then we can solve by adding the 2x to both sides. We're going to get 4x plus 10 equals 90. Then we can subtract 10 from both sides. We have 4x equals 80. And then when we divide both sides by 4, we see that x has to be 20. Now, this question is a little tricky for us, and here's why. It gives us a hint right there. Find all values of x. So x equals 20 was just one possibility. Instead of that, what happens if those two angles were congruent to each other? So then we would have had 80 equals 90 minus 2x. In this case then, we would have subtracted 90 from both sides. Get negative 10 is equal to negative 2x. Then we'd have to divide by negative 2. And then we would see that our answer is x equals 5. Oh, I should circle that actually. So that was a possible answer for us, was that x could have been 5. But that's still not all the possible values, because there's one last combination we could have had. We could have had 80 congruent to 2x plus 10. So we need to set those equal to each other. Subtract 10 from both sides. 2x is equal to 70, and then we have to divide both by 2. So the last possible answer we could have had was that x was 35. So this question was a little tricky. Just to warn you, there have been a couple exams in the past that have had a question like this where you had to find all the values. So just make sure that you are reading the directions carefully and know that this is a possibility where you may need to find 3 different answers. Okay, this one I hope will be a little bit simpler. So you need to find x. There's only one answer this time. Pause the video. When you are done, I will show you how to solve it. Okay, now that you have attempted this question, I'm going to show you how to do it. So the first thing is, let's focus on this triangle right here. We already know 2 of the angles. We know 55, we know 90. We're just missing this angle right here, which I'm going to label as y. So in order to find that angle, we need to do 180 degrees minus the other 2 angles that were already given. So we know minus 90 and then minus 55. Well, here on the left side, I see that 180 minus 90 is going to be 90. Then we just need to subtract 55, and that's going to leave us with 35 degrees. So y, let me erase that. That angle had to be 35 degrees. Now that we have found that one, we are able to solve for x, because we should be able to see that x and 35 make a linear pair. So we should add x plus 35 and set that equal to 180. Then we just need to subtract 35 from both sides. And that leaves us with x equals 140. 45 degrees. All right. Once again, I want you to try this on your own. So use what you've learned about triangles and some of the angle pairs that we talked about in the past so that you can solve for x. Pause the video, and when you are done, I will demonstrate how to solve it. Okay, now that you have done this, what I see is this big, we've got this big x right here in the middle. And hopefully you remember that when you see a big X or maybe the V, that we have vertical angles. The X right here is going to be congruent to that angle that I just drew in right there. Now that we've done that, we can just focus on this triangle here because all three of those angles are supposed to add up to be 180 degrees. So we should go ahead then. We can just do either add all of them together, or if you want, you could just subtract from 180. 180 minus 70 degrees minus 40 degrees is going to be equal to x. And we see that we've got 110 minus 40, and therefore x had to be 70 degrees. Okay, the last thing that we are going to talk about here is the triangle inequality theorem. So sometimes you are going to be given three potential side lengths for a triangle, and you need to determine if it is possible for the sum of those two sides to be larger than the third. And this inequality is what we're going to use to determine that. A plus B must be greater than C. Notice how it does not say equal to, it must be greater than. So I'm going to give you just a couple examples here on this slide to kind of explain why this is the case. I'm going to first do a triangle that possibly has side lengths. Let me redo that. I'm going to say that I've got, no, I don't want to actually draw it yet. I want to have 2, 2, and 4. And I'm going to explain to you why a triangle cannot exist with those side lengths. So let's say, since 4 is the longest side, now I'm going to draw an angle, draw a side that had to be a 2. I'm going to draw another side that also had to be a 2. Well, we have a problem. I've kind of demonstrated right here that these are never going to touch. And in fact, I think I have an even better way that I could demonstrate this. I'm going to use a different color. I'm going to pick black. And what I'm going to do is, let's see, what's the best way that I could do this? I'm going to try to draw it right above. And I'm going to try to get half of this. So let's see if I have about half. I need it a little bit longer. I'll cheat and I'll just shorten the other. I'll shorten this down here. Oops. Okay, that's good enough. So here's what we are going to do then. If both of those black segments that I just made are 2, I am going to take this and I'm going to attempt to rotate it without changing its length. So if the red there is 4, and each of these are supposed to be 2, well, there's no way that they're ever going to connect with each other unless they're down here and they're laying right on top of the side that was 4. And that isn't even a triangle, that's just a line segment. So therefore, if 2 of the sides happen to add together to be equal to the third, there's no way a triangle can possibly exist. It's just going to be a line segment. So that's what we get with the triangle inequality theorem. Okay, so we're going to finish off then just by trying to identify if triangles can exist. So you don't want to be trying to draw these. That's not the correct way of solving it. All you need to do is you just need to pick 2 of the sides, add them together, and see if they will end up being larger than the third. So what I'm going to do here is I'm just going to start with 1 and 2. And we need 1 plus 2 to be greater than 3. And in this case, we can see we're going to get 3 is greater than 3. Well, that's false. That's not possible. So that means then that for number 1, no, we cannot make a triangle with those side lengths. Okay, down below for letter B, they're all 4, so it doesn't matter which ones we choose. We just need to do 4 plus 4 and show that is greater than 4. When we simplify, we get 8 is greater than 4. That is a true statement. And therefore, yes, we are able to make a triangle using side lengths of 4 for all of them. And in fact, that would have just been an equilateral triangle anyway. Okay, for letter C, 6, 7, and 8. So what we should do, we should add 6 and 7 and see, is that greater than 8? Well, we've got 13 is greater than 8, so that one works. Then we should show another combination. 7 plus 8 is supposed to be greater than 6. We get 15 is greater than 6. That also works. And then finally, I am going to try 6 and 8. And that needs to be greater than 7. And we do get 14 is greater than 7. All of those are true. And therefore, a triangle does have to exist using those 3 side lengths. Okay, then the last one. We have 4, 8, and 3. So I'm going to start with the first one. Does 4 plus 8 end up being greater than 3? It does. We get 12 is greater than 3, so that's good. Then the second combination I'm going to do is 8 plus 3. And that is supposed to be greater than 4. We get 11 is greater than 4. That works. Finally, we have to test 4 plus 3 and check if that is greater than 8. And what happens is we actually get 7 is greater than 8, which is false. And so therefore, for this last one, no, a triangle cannot exist. Alright, so that is everything. Your homework is going to be a worksheet. Make sure to check Savas Digital Platform. I'll let you know which questions are required and which ones are optional. Thanks for listening, everybody. Have a good day.